Hello everyone, welcome to Big Boy Physics, and in this video I'll be covering a problem from the topic of electromagnetism, and this problem is taken from APHO 2000. That is the third problem, right? And the name of the problem is the Stewart-Tolman effect. In 1917, Stewart and Tolman discovered a flow of current through a coil wound around a cylinder rotated axially with certain angular acceleration. Consider a great number of rings, each of radius tau, made of thin cylindrical metallic wire of resistance R. Okay, they are saying that these all the wires are made of thin metallic wires of resistance R. Now the rings are put in a uniform way on very long glass rod. Okay, which is vacuum inside. Their positions on the cylinder are fixed by gluing the rings to the cylinder. Now, the other informations given is that the number of rings per unit length along the symmetry axis is n. The planes containing the rings are perpendicular to the symmetry axis of the cylinder. At some moment, the cylinder starts a rotational motion around its symmetry axis with angular acceleration alpha. Okay, this alpha they are saying about angular acceleration, not about any linear acceleration. Then you have to tell me the magnetic field at the center of the cylinder after a sufficiently long time. We assume the electric charge E of an electron and mass m to be known. So pause the video for some time. We'll be getting started. So coming to the solution. Now one thing you must know about something called the Drude's equation. Well, Drude's equation I'll be discussing now in a very brief way, but I'll be taking up some topics about Drude's equation and some problems in some later videos. Now, Drude's equation also involves that a electron which is moving under a constant drift velocity, which we averagize, then you'll get a constant velocity along the direction of the wire. Then the contribution is due to electric field, the electric field, some other forces, any forces due to which is pushing the electron, and there will be also a contribution due to viscous force. There will be kind of a drag force on the electron which will try to bring it to a steady current state. That is why we get a steady current, right? So this is the concept of Drude's equation. Now the similar concept that when the ring starts to rotate, when the ring starts to rotate, the medium correspond to the ring will start to rotate. When the ring starts to rotate with angular acceleration alpha, then what will happen that the medium corresponding to it will start to rotate. Now electron is at rest. Observe the blue dot to be the electron. Electron is with respect to rest with respect to the lab frame. Now in the frame of the cylinder or the ring, better to say the ring, in the frame of the ring, it will appear to move in the opposite direction with angular acceleration or with the acceleration alpha r. So what will happen that the viscous force will try to slow down the electron, and this way there will be a steady current generation in the coil. Okay, and this is the main concept or the core concept behind this problem, that how the electrons will start to move, how the electrons will react to the movement or the rotation of the coil around with respect to the symmetry axis. This was the key concept involved in this problem. Okay, now observing with respect to the coil frame, you can say that with respect to the coil frame, what will happen basically is that the medium and the electron will be moving with same velocity, but the thing is that it will experience a force m alpha r, or let it be tau. We'll keep it r only because probably they have given the answers in terms of smaller, so let it be smaller. So this is the force on the electron. Now, symmetrically, an electric field E vector will be generated opposite to the direction of the motion of the electron, so that, well, it will be in the same direction. Apologize me for the mistake. It will be in the same direction in the motion of the electron, because the force on the electron will be acting opposite to the direction of the electric field. So what will happen is that an electric field will be induced along the coil in the circular direction. What will happen basically, this will try to nullify the force acting on the electron. So ee, that is small e into capital E, that is the force acting on the electron due to the electric field, will be equivalent to m alpha r. Hence I can say that E, that is the electric field which will be generated in the wire, will be m alpha r by E. This is equation 1. We know that current density J is given as E by rho. So I can write it as m alpha r by rho E. Now let us assume that the cross section of the wire has area small a. So current I will be J into small a. You'll get m alpha r by rho E and A. We know resistance R is given as rho into 2 pi R by A. So I can write rho by A to be R by 2 pi R. Just substituting rho by A the same, we'll be getting something like R into 2 pi R. Finally, you will get 2 pi m alpha small r square by electronic charge into resistance of the coil. So this is my current which will be induced in the coil after a long time. When the steady state will be attained, this will be the current which will be virtually flowing through the wire due to the motion of the coil. Now you know the magnetic field. It's easy to derive. Magnetic field B for a solenoid is given as mu naught Ni. Just substituting the formula, we'll get 2 pi mu naught m n alpha r square by small a into capital R. And yeah, that's the answer. Hope you enjoyed this video, and I'll be bringing up more problems for in the upcoming sessions. Well, some people are commenting me about bringing few theory series and for getting more, being more capable of problem solving. So yeah, stay tuned. I'll be trying to take out time and bringing some theory concepts and important concepts which will be helping you for JEE, NEET, Olympiads, everything which is possible. So hope you enjoyed this video. Thank you and have a nice day.